Hello everyone. Today we shall discuss chapter 7, that is triangles. Today is a class of introduction, so we will introduce the different aspects of triangles. First of all, we will go to a definition. You see here, this is the introduction. You have studied about triangles and their various properties in your earlier classes. You know that a closed figure formed by three intersecting lines is called a triangle. Tri means three. A triangle has three sides, three angles, and three vertices. For example, in triangle ABC, denoted by triangle ABC, AB, BC, CA are the three sides, angle A, angle B, angle C are the three angles, and ABC are the three vertices. We know all these properties. Now we will talk about congruence of triangles. What is the meaning of congruence of triangles? You must have observed that two copies of your photographs of the same size are identical. Similarly, two bangles of the same size, two ATM cards issued by the same bank are identical. You may recall that on placing a 1 rupee coin on another printed in the same year, they cover each other completely. Do you remember that such figures are called? What such figures are called? Indeed, they are called congruent figures. What is the meaning of congruent? Congruent means equal in all respect or figures whose shapes and sizes are both the same. That is congruent, right? Congruent means equal in all respect. For example, if we draw two triangles, suppose this is one triangle. This is one triangle ABC. This is a triangle ABC. And there is another triangle. Suppose this one. This one is DEF. This one is DEF. Now if we compare both these triangles, see, suppose this is DEF. This is the vertex of this triangle ABC, and this is the vertices of triangle DEF. D is the vertex E and F. A, B, C, these are the vertex. That means this triangle will be congruent if they are equal in all respects. What is the meaning of equal in all respects? That means their sides are same. That means this AB corresponds to this side D. That means AB should be equal to ED. Not only that, this corresponding side BC should be equal to EF, and AC should be equal to DF. That means corresponding sides are equal. Not only that, angle A is equal to angle D. This is the corresponding angle. Angle B is equal to angle E. Angle C is equal to angle F. Then we can say that both the triangles are congruent to each other. And the same symbol for congruent is in this way, right? Congruent. That means we can say that triangle ABC is congruent to triangle DEF. The meaning is that they are equal in all respect, means they are equal in their sides, equal in their corresponding sides, corresponding angles, and corresponding vertices also. That is the meaning of congruent. Congruent means their shape and size should be the same. Congruent means equal in all respects or figures whose shapes and sizes are both the same. Right? This is the definition of this meaning of congruent. Right? Now we'll rub this one and you see what are the next right? Now you see, congruent means equal in all respect or figures whose shapes and sizes are the same. Now you see, if we draw two circles, right? If we draw two circles, now you see here how you are comparing with each other. Suppose these are two circles. Here we are taking two circles. Suppose this is one circle, right? And if we take a duplicate circle in the same way, that is, if the radius is same, right, then they are equal in all respect, right? Suppose this one is a circle, and if you do another circle, suppose this is another circle, and we compare the circles. What do we compare? We are comparing, if we compare the circles, and if we find that, suppose this is the center of the circle, right? Here you see, suppose this is the center of the circle. We have to take another circle. Suppose we are taking another circle here, and we compare both the circle, right? How to compare? Suppose this is the center of this circle. This is the center of this circle, right? This is the center of this circle, and the radius of this circle, this is the radius. If the radius, suppose this is the radius, this is the radius of this circle, and this is the radius of this circle, suppose. And we see that both the radius are equal. The radius are equal. R1, suppose this is R1, and this is R2. If the radius is equal, R1 is equal to R2, R1 is equal to R2. The centers are equal. The C1, this is C2, center. C1 equal to C2, C1 is equal to C2. And also the circumference of this triangle, circumference. Suppose the circumference, what is the circumference? Suppose C is equal to 2 pi R1, 2 pi R1. This is the area of the circle, right? Area, we can say it as A, suppose A1 is equal to A2, A1 equal to A2, and that is equal to pi R2, 2 pi R, that is circumference. Suppose we will find the circumference, that is, it is represented as C3, and it can be represented as C4, 2 pi R2. That means their circumference are equal, right? And not only that, if we compare the areas, that is A1, area of a circle is pi R1 square, pi R1 square. And the area of the circle A2 is equal to pi R2 square, pi R2 square. And if all these are same, that is A1 equal to A2, then you can say that these are congruent to each other. Congruent means in all respect, their radius will be equal, their centers will be equal, their circumference will be equal, and their areas will also be equal. You see here, A1 equal to A2. This is the area, right? Then we can say that these circles are congruent to each other, right? Congruent means they are equal in all respect, right? That is congruent, right? In this way, we can say that what is the right? That means these two circles will be congruent or when their radius is r1 is equal to r2. Radius is equal, right? The centers are equal. C1 is equal to C2. Their circumference will be equal. That is pi r of 2 pi r1. 2 pi r1 is equal to 2 pi r2. 2 pi r2. And the radius is also equal. That is pi r1 square is equal to pi r2 square. Only then you can say that these two circles are congruent to each other. That means they are equal in all respects. Their radius will be equal, their centers will be equal, their circumference will be equal, and their areas will be equal. Only then you can say that these circles and these circles are congruent to each other. Congruent means they are equal in all respect. That is the definition of congruent, right? Now we are going back to the same, right? Now you see, this is what we say about congruence of triangles. That is, congruent means equal in all respects or figures whose shapes and sizes are both the same, right? We have already discussed about the circles. Now we will compare it with a square. Suppose this is a square. If we take two squares, what will happen to that? That I want to know. Suppose this one, right? If you rub this one, now if we take suppose two squares, then what will happen? Then you see this one. If we take squares, right? Let us do example of square. Suppose let us take two example of a square. Now we are going to take two squares. Suppose we are taking two squares here, right? You see here we are taking two square. One square is here, right? And another square, if we take this one is another square, we are taking this one. Suppose this is a square. When we say that these two squares are congruent to each other, first of all, you see, if we say two squares, these two squares will be equal only when their corresponding sides are equal. Suppose this is A, B, C, D, A, B, C, D, right? This is E, F, G, H. These two squares will be equal only when their corresponding sides are equal. That is AB is equal to EF. BC is equal to FG. DC is equal to HG. AD is equal to EH. All the sides are equal. Not only that, the angles, this is 90 degree, this is also 90 degree. This is 90 degree. Corresponding angles are also 90 degree. This is 90 degree. This is 90 degree. This is 90 degree. And this is 90 degree. Then you can say that these two squares are congruent to each other. Congruent means they are equal in all respect. If you find the area of this square, area A1, area means side into side, that is length square, or you can say it as DC square. Area of this square A2 is equal to HG square. Since DC is equal to HG, therefore their area will also be equal. That means these two squares will be equal only when their corresponding sides are equal, corresponding angles are equal, their area is equal. Then we can say that these two triangles, these two squares are congruent to each other, and if we take these squares on this square, they will overlap with each other, right? They cover completely with each other, and that is the meaning of congruent. And in one line we can say that congruent means they are equal in all respect. That is the meaning of congruency, right? That means their corresponding sides are equal, their corresponding angles are equal, and the areas will be also equal. That is the meaning of congruency. Now you see, we will take other examples like this one. Which of the triangles given below are congruent to triangle ABC in figure 7.41? You can see here. See, we will see which one are have the same corresponding sides should be equal and corresponding angles should be equal. Only then you can find that these they are congruent to each other. Suppose if we compare this one, right, this is 4.5, this is 4 and this is 5 centimeter, right. If we compare this one, then you see this one 4 and 4.5, this is EF 4 centimeter is equivalent to this corresponding side AC. DF 4.5 corresponding to AB 4.5 centimeter and BC 5 centimeter, right. In this you can say that they are congruent to each other because their sides, corresponding sides, and if corresponding angles are equal, you can say that they are congruent to each other, right. In this way you can find the various properties. That is, here see PQ covers AB, QR covers BC, RP covers CA, angle P covers angle A, angle Q covers angle B, angle R covers angle C. Also there is a one correspondence between the vertices. That is, P corresponds to A, Q corresponds to B, R to C, and so which is written as P corresponds to A, Q corresponds to B, and R corresponds to C. Note that under this correspondence, triangle PQR is congruent to triangle ABC. But this will not be correct to write triangle QRP. QRP is congruent to triangle ABC. Why? Because corresponding vertices should be there. That is P. You see here, in this way you can see that triangle PQR will be congruent to triangle ABC because P corresponds to A. You can see here that P you can see here that P corresponds to Q here, right. You can see that P corresponds to A, Q corresponds to B, and R corresponds to C. In this way you have to write that triangle PQR is corresponds to triangle ABC, but this is not the case, right. You cannot write in this way because Q doesn't corresponds to A, because P corresponds to A, Q corresponds to B, and R corresponds to C. This is one correspondence between the vertices. In this way you can say that this triangle is congruent to this triangle, right. Now we'll see other aspects or various aspects of this chapter. Also you can see here that similarly for figure 37.43, FD corresponds to AB, D corresponds to BC, EF corresponds to CA, and F corresponds to A, D corresponds to B, and E corresponds to C. So triangle FDE is congruent to triangle ABC. But you cannot write in this way that triangle DEF corresponds to triangle ABC. That is not correct. Why? Because here you can see that F corresponds to, you can see here that F corresponds to A, D corresponds to B, E corresponds to C. Only then you can write in this way that FDE corresponds to triangle ABC, right. In this way you have to write, right. In this way we can write the different correspondence, right. Now we'll go to next step, that is, you can see here, that is, note that in congruent triangles corresponding parts are equal, and we write in short CPCT for corresponding parts of congruent triangles. Corresponding, this is CPCT, that is for corresponding parts of congruent triangles. You have to remember this word CPCT, corresponding parts of congruent triangles, right? I already told you what is the meaning of congruent. Now we will discuss about the criteria of our congruence of triangles. What are the different criteria for finding the congruence of triangles? In earlier class we have learned 4 criteria for congruence of triangles. Let us recall them. Now you can see that we have 4 axiom. We will read about axiom 7.1. 7.1 side angle side congruence rule. What is side angle side congruence rule? You can see two triangles are congruent if two sides and included angle of one triangle are equal to the two sides and the included angle of the other triangle. What is the meaning of this? First we will read this one, right? Side angle side. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other angle. First we will define this one, right? In this way we can define. Here you see that two triangles. We are taking two triangles, right? First of all we will now see we are taking a new slide here, new slide, right? Now you see what is the meaning of this. Suppose we are taking two triangles here, right? You can see we are taking two triangles. This is triangle number 1. If we take this yellow, it is triangle 1 and this is triangle 2. This triangle we have taken, right? And if we write the different names of this triangle, let us take another triangle, right? What is the meaning of this? You have to find this one, right? This is the two triangles we have taken, right? Now you see if we take the name of these two triangles, suppose we are taking the name these two triangles. Suppose this is ABC. The name of this triangle is ABC. A. This is B. This is C. This is D. This is E. And this is F. Right? What is the criterion? The criterion we have already read about is what we call it as side angle side. What is the meaning of this side angle side criterion? Side angle side. Suppose we know that in this two triangle AB is equal to DF, right? And BC is equal to EF, right? And what is the included angle? You can see that these between these two sides, this is the included angle, not these two. Included means between these two sides, right? That means this one angle B and angle E, right? That means this is side, this is one angle and this is another side. That is side angle side rule. This is one side, this is angle and this is side. That means this is what we call it side angle side rule. Side angle side rule. That is rule number 1. What is rule? Congruent rule. Side angle side. That means these two sides and one included angle. Again you can write in this way that AB is equal to D. Angle B is equal to angle E. Side BC is equal to side EF. Then we can say that triangle ABC is congruent. This is the symbol of congruent to triangle DEF. You have to write DEF. Why? Because A corresponds to D, B corresponds to E, and C corresponds to F. In this you have to write. that is side angle side rule. This is axiom, this one, that is axiom number side angle side congruence rule. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Now you can here you see that if we compare these two triangles, right? This side is equal to this side is equal to this side, and this angle is equal to the angle to this angle, and they are congruent to each other, right? By the congruent rule of side angle side, and this is axiom 7.1, right? This is side angle side, corresponding sides should be equal, right? And the included angles means between the two sides, that is included angle, right? That is side angle side. Now the next criterion will read. The next criterion is this one, that is second criterion. You see here the second criterion is side angle side congruence rule holds but not angle side side or side side angle rule. This you have to remember, that side angle side only is the congruence rule holds, but not angle side side or side side angle. This is not correct, right? Now you see the other different aspects of axiom, that is theorem 7.1. Angle side angle congruence rule. You have to remember angle side angle congruence rule. Two triangles are congruent if two angles and the included side of one triangle are equal to two angles and included side of the other triangle. What is the meaning of this? If we take two triangles, suppose let us take two triangles, right? Here let us take a new page and you'll find, suppose we are taking two triangles in this way, one triangle, and let us take one triangle, another triangle, that is suppose this triangle we are taking, another triangle you will take this one, suppose again we are taking this triangle. Now what is the congruent rule? The congruent rule is, here we are discussing about is this one, that is this rule. You have to remember angle side angle congruent rule, angle side angle, right? Angle side angle. How we will compare this angle side angle rule? Angle side angle. Suppose this is the name of these triangles are. Let us take another triangle first. Here you are taking another triangle, right? Now let us take the names of these triangles, right? Suppose this is ABC, A, this is B, this is C, this is D, this is E, this is F. Angle. Suppose this angle is equal to this angle, that is angle B is equal to angle E, right? And this side BC is equal to EF. BC means here BC is equal to EF, EF. And this angle, angle C is equal to angle F. Angle C is equal to angle F. Then you can say that the two triangles are congruent by the rule angle side angle. But you have to remember that these sides should be included between the two angles. This side should be included between the two angles, this angle and this angle. This is the included side. This is what we call it as included side. Included side. Included side. This is included side. Right? That means this criterion rule is angle side angle. Angle side angle. This is criterion 2. Right? In this way you can find out the different congruent rules. You see, angle side angle. This one is angle side angle. Now we'll go to the next phase. Right? Here you can see that this is theorem 7. angle side angle congruence rule. Two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side, this is included side of the other triangle. This is the theorem 7.1, right? Now here you can realize that there is a point here, that this one, here you see, here two triangles are congruent if two pairs of angles and one pair of corresponding side are equal. We may call it as angle side congruence rule also, right? That means angle side congruent rule we can also call it, right? That is, two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. We call it as angle side, right? Angle side congruence rule, right? Angle side congruence rules. Now we will go to the next phase. Next phase is, see this one, right? Now we will find another phase, that is right hypotenuse side, RHS rule, right? What is that right hypotenuse side rule? RHS. Now we will find it as right hypotenuse side, RHS rule. The next rule we will deal with is RHS. 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 What is the meaning of RHS? Right hypotenuse side. Right hypotenuse side. Hypotenuse. Right hypotenuse. Right hypotenuse side. This is RHS congruent rule. RHS congruent rule, we call it as congruent rule. RHS congruent rule. Now we will find what is that RHS congruent rule. Let us take in the same way two triangles. Suppose we are taking here two triangles. You see here we are taking two triangles here. One triangle is this one and one triangle is this one. We have taken two triangles, right? And if we name it as ABC, name it as ABCA. This is A. This is A. This is B. This is C. This is D. This is E. And this is F. I know that this is a right angle triangle, right? Because this is 90 degree. In the same way, this is also 90 degree, right? I know that angles opposite to 90 degree is called it as hypotenuse. We know all these things. Hypotenuse. This is hypotenuse. And here, if the hypotenuse is same, AC is equal to DF, hypotenuse. That is, hypotenuse AC is equal to DF. And angle B is equal to angle E is equal to 90 degree. That is, you can say it as right angle. We can say it as a right angle, right? And here you see any of the two sides, either AB is equal to DE or BC is equal to EF, then we call it as right hypotenuse side congruent rule. First one, hypotenuse should be equal, this hypotenuse should be equal to this hypotenuse. Both are 90 degree or right angle, this angle and this angle is 90 degree. And any of this side, either AB is equal to D or BC is equal to EF, then we call it as right hypotenuse side congruent rule. Right hypotenuse side congruent rule. Right hypotenuse side congruent rule. These are the different congruent rules we already discussed about it. Right? This is right hypotenuse side congruent rule. Let's go back to the here you see that we already discussed all these properties of triangles. These are the different congruent rules, right? These are the different congruent rules we discuss. Now you can see here there are other properties also. This is based on sides. Later on we will discuss all these. Some more properties of a triangle. Now you see, we know all these properties. Even then we are again discussing about it. Theorem 7.2. Angles opposite to two equal sides of an isosceles triangle are equal, and the result can be proved in many ways, right? Angles, what is the meaning of this one? Angles opposite to two equal sides of an isosceles triangle are equal. What is the meaning of this one? We are not going to prove this one, but we are taking this. Let us how we can prove this one, right? Let us take another page, and here you can see here you see, if we take an isosceles triangle, suppose this is an isosceles triangle, this is an isosceles triangle ABC, A, BC, BC. Suppose this side AB. What is the rule you see here? First, angles opposite to equal sides of an isosceles triangle are equal. What is the meaning of this one? You see here, that is, suppose two sides are equal, AB is equal to AC, AB is equal to AC, AB is equal to AC, and means this side is equal to this side, and the angles opposite to AB is angle C, and angle opposite to side AC is angle B. That means angle B equal to angle C. This is the theory. This is the axiom, that if the angles, what is that? That is, it is given that angles opposite to equal sides of an isosceles triangle are equal, and it should be an isosceles triangle, right? Angles opposite to the sides, equal sides, will be equal. That is, if AB equal to AC, then angle B will be equal to angle C in an isosceles triangle. This is the theory of this one. That is axiom 7.12. This is the axiom. You see here, angles opposite to equal sides of an isosceles triangle are equal. This is theorem 7.2. We can prove this also, but now today we are not going to prove this one. We are only recalling all these rules. This is 7.3. The sides opposite to equal angles of a triangle are equal. The sides opposite to equal angles of a triangle are equal. What is the meaning of this one? This is the converse of theorem 7.2. The sides opposite to equal angles of a triangle are equal. Let us find this one. Suppose this is a triangle. This is any triangle. Suppose we are taking this triangle in this way, right? Suppose this triangle is DEF, D, E, F. If DE is equal to DF, here you see, if DE is equal to DF, then the opposite of side DE is angle F, that is angle F. The opposite F is angle E, then DA angle F equal to angle E. This is the axiom. This is the converse of the before that, right? This is the converse. Now you can see here what is given here. The sides opposite to equal angles of a triangle are equal. That means that if the two sides are equal, their angles will also be equal, right? This one. Or if the angles are equal, then the two opposite sides will be also equal. This is the converse of one to another, right? Now you see the next phase. We are going to the next phase. You see, that is the converse of theorem 7.2. The sides opposite to equal angles of a triangle are equal, right? Next, we are going to the next phase, that is what we call it as, this is 7.2, exercise 7.2, and now we are going to the next phase of this chapter. Some more criteria for congruence of triangles. You see here, there is another criteria you already rule. Now this is theorem 7.4, side congruence rule. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. What is the meaning of this? Let us take this one. Suppose we have taken two triangles. You see here we are taking two triangles. This triangle, let us take this one triangle. One triangle is here, one triangle, right? And let us take another triangle. Suppose we are taking another triangle here. These two triangles will be congruent if you see here. Let us take another page, and suppose this is one triangle, this is one of the triangle, right? And let us take another triangle also, suppose this one, and write it here as this one. And you see, if we compare these two triangles, right? Now if we write the name of these triangles as, if you write the name of these triangles is as ABC A, BC B, C, and DF D, E, F. And if AB is equal to D, that is corresponding side. AB is equal to D, these are the corresponding sides. BC is equal to EF, and AC is equal to DF. Then you can say that triangle ABC is congruent to triangle DEF. If you write in this way, because A corresponds to D, B corresponds to E, and C corresponds to F. In this way you can find that this is side angle side rule. By side and side rule, congruent rule, these two triangles are congruent to each other. And I already told you what is the meaning of congruent. Congruent means they are equal in all respect. This in all respect means their side will be equal, their corresponding angles will be equal, their areas will be equal, all these will be equal, right? In this way you can say it as congruent to each other. That means by side congruent rule, if three sides of one triangle are equal to three sides of another triangle, then their two triangles are congruent, right? Right now the next one is this one. What we have already discussed about it, right hypotenuse side congruent rule. If in two right triangles the hypotenuse and the one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. We already discussed about this one, that is right hypotenuse side. We already discussed about all this. Now we'll recall what theorem we have read about, right? Here you can see this is 7.4, 7.3. We will solve all the questions of this chapter one by one. Before that, we are going to recall the congruent rules. Here you see the first congruent rule is what we call it as side congruent rule. Side congruent rule. That is rule number 1. Side congruent rule. Number 2 is right hypotenuse side congruent rule. Right hypotenuse side congruent rule. Congruent rule. Number 3 is side angle side angle side congruent rule. Congruent rule. And number 4 is angle side angle congruent rule. It can be also written as angle side congruent rule, right? These are the different congruent rules you have to know, right? These are the different congruent rules. Side congruent rule, right hypotenuse side angles. You have to remember that this should be included angle and this should be included side, right? These are the 4 different congruent rules we have already discussed about, right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.